I'll just so what is ROS? So ROS stands for I show so what is ROS? Who is watching currently? What is ROS? Question mark into 10 raised to the power 23. So I'll just ROS stands for Robot Operating System. So what is ROS? So ROS stands for I show so what is ROS? Who is watching currently? Yeah, yeah. So what is ROS? So ROS is a robot operating system. ROS stands for robot operating system. It's basically a operating system for robot. So uh, why an operating system? So why not use an operating system? So the problem with normal programs is that you will have to reprogram. You have to rewrite every code every single time if you want to use a different robot. But what about operating system? ROS can easily be implemented in any other robots. So let's understand ROS. So ROS has a system called topics and messages. So as you can see in topics, a publisher publishes some message to the topic, and the subscribers subscribe to the message. So like this. So publisher has sent a message that India has gained independence in 1957. This is the string. So now the subscribers will subscribe to that. So and then there are services. So services like call a function inside another node. So it works on a client and a server. The client says, what's the square root of 9? The server says square root of 9 is 3. So these are called as request and response. So the client requested what is the square root of 9, and the server responded by saying that the square root of 9 is 3. So let's understand actions. So in actions there is a goal, there is a feedback, and there is a result. So let's understand actions. So the parent says, make our son a doctor. Then the teacher says, your son is performing good in music class, he can become a musician. It's a feedback. But the son becomes an engineer, and this is the result. So yeah, so the topics can be used for sending sensor data and stuff. The services can be used to like calculate and stuff, and the actions are the main so the actions are like, hey robot, go to that position, and the robot while going to that position will give you a feedback that I am here, there is a obstruction ahead, I will take the other path, and so on. So the actions are great for like giving a goal and stuff. The services like it's like calling a function inside another node. So you understand basically how ROS works. So now let's see why we have to use ROS. Instead we can use a microcontroller or an Arduino. We can just simply program. So why use an operating system rather than a simple program or a software? So the best thing about ROS is that it has stacks, like it has a navigation stacks, and it has different topics for different sensor data. So everything is nearly pre-built in ROS. So ROS can be development of robot in ROS is very fast, and you can just simply download any package to install in ROS. So to understand the difference between ROS and a program, we first need to understand the difference between a microcontroller and a microprocessor. So a microcontroller is best for tasks like turn on the light 1. So like it can do that at, like it works on higher voltage, like we can do like turn on the light 1 at 200 volts, like we use the relay for that, but not a microcontroller, but okay. And the difference between a microprocessor is that processor can process data very easily. So like processor is best for cameras, navigation, computing stuff. It can run OS and graphics and games. So now the difference between ROS and programs. So now what program we have to do in program is, like if we write a program for robot A, which has a wheelbase, right, which has different sensors, sensor A, sensor B, sensor C. So if we use the robot A's program for a robot B that uses sensor Z, sensor Y, sensor X, so it will not work because the A's program is for sensor ABC only. But what about ROS? In the ROS anything can publish to a topic. So sensor A will publish to value A, and the same value is used by sensor Z. So sensor Z can also publish the value to value A. Like you understand. So the ROS decreases the amount of time we have to rewrite a code again and again. So and also for the subscribers, so if like motor A cannot run at the same value B, so like if motor A subscribes to value B and motor B can also subscribe to value B, that's the uniqueness of ROS. You can easily make any robot very easily. Its ROS is mainly used as for robots, mobile robots. Wow. Mobile robots, cause mobile robots require a thing called navigation, and navigation is very important for mobile robots. Now in ROS there is a thing called navigation stack, and in navigation stack we can put values like LiDAR scans, we can put like camera, image, raw images, and so you understand that ROS is basically very good for making robots very fastly and making different robots very easily. So now you understand what is ROS. So how do you get in ROS? That's the main question. Many of So the best way to get in ROS is first dual boot your laptop or PC to Ubuntu. If you don't have Ubuntu, dual boot it. Uh, VMs VMs don't work on many computers. VMs are very bad for ROS. Not that bad, but it's more preferred to use a dual booted system. So now, how do you learn ROS? The best way to learn ROS is to go to ros.org. Here, go to the wiki.ros.org to the tutorial page and complete all of these beginners tutorial. So we'll just do a simple beginner tutorial. So I will assume you will have completed till the fourth level. So we will start with ROS nodes. No, I have done that. So now the first thing that you should run while using ROS is ROS core. So ROS core is like the heart of the ROS. So I'll just make, and yes, I am using Terminator here. You can watch Pranshu Tople's videos on how to set up Ubuntu for ROS. Terminator is pretty useful tool. Like we can easily split terminals in half, and it's pretty easy to do development here. I like to keep the top left corner for ROS core. So as you can see, we have started the ROS core service. Not a service, ROS core, and then we will let's see what ROS nodes are currently. You should probably get used to Linux. So the current ROS node that is running is /ROS out, and it's right here. We can see that the ROS core starts ROS out. So now let's follow on the tutorial. Yeah, we can see that there's a ROS out, and now if we use the info command, /ROS out, we can easily see that there are gate loggers, there is set logger level, and the publisher is ROS out /agg, and the subscription is ROS out. So the types of messages, it is a ROS graph message. You can easily see there. This is the type of the message. So now let's do the turtle sim tutorial. So now you will probably be very angry for why ROS has used this has put this in here. It's so that you cannot simply copy paste. Why do they not want you to copy paste? That's for you to learn how the commands are typed. Like it will get in your muscle memory. Turtle sim ROS run tap turtle sim _ node. Yeah, so So as you can see, our turtle is now here. Now we will run turtle sim, turtle tab daily tab, and now remember one thing here. Should just go. I will just copy paste it. Wow. Yeah, so remember to keep the terminal that's running the teleoperation key in your focus. So now if I press my front arrow key, up arrow key, you can see that the turtle starts moving forward. And if I use my left or right arrow key, you can see that the turtle rotates like that. Like I can draw a mountain here. Let's draw a house. Let's try drawing a house. You at 90 degrees, man. Yeah, a very bad house. It's a very bad house. It's looking like a hexagon than a house. So now, if we look at the ROS node list, new terminal. Now there is teleoperation turtle, which we launched here, and there is the turtle sim, which is here. We'll just like you can change the name of the nodes like that. Now let's look at how ROS topics run. Yeah, so we have ROS core, we have turtle, we have teleoperation key. Now let's run arithmetic graph. So for that I'll go in a different workspace, split, and now you can run the arithmetic graph. I will just give some basic introduction to the topics, and we will end there. So now as you can see here, the node teleop turtle is sending a message to the topic command velocity to the node turtle sim. So now this is publishing to that topic to here. So now here it's on. So now let's look what is actually happening there. I will just do it on here. First topic echo 1/cmd. Now bad, and just do it here. Cross run slash turtle 1 slash cmd well and let's run. Wait, ROS topic. we are using the wrong command. Slash turtle 1 slash command velocity. We have to put echo here. Echo. Now if I put, like you can see, the linear on x is 2 when I press the front arrow key. You can see it. And when I press the left or right, you can see the angular velocity of z axis is changing. As you can see here, the turtle is also changing. So let's look at the graph currently. So now let's refresh the graph, and you can see this is publishing to the command velocity topic, and there are 2 nodes which are subscribing from the topic using ROS topic list. We just did it. Now for let's see what type of message is this giving us. We will just end our stream after this tutorial. ROS topic type on this is this. So yeah, so you can see the command velocity topic is a type of message. It is geometry dash messages slash twist. So now we look at what's the type of the topic. ROS topic slash turtle 1 slash command velocity. Type. Yeah, so we can see that this topic is the type of geometry message slash twist. So now let's just try. So using ROS message, we can look at what kind of the message is that. ROS message show geometry twist. Geometry slash messages. I'm stupid. Slash twist. Yeah, so you can see that the format of this message is linear velocity. So like vector 3 linear and vector 3 angular. So vector 3 means a vector in third dimension. I worked in game dev for some time, so there is vector 3 and there is vector 2. So vector 2 only has x and y, and vector 3 has x, y and z. So x, y and z, these all are type of load 64. So that means it takes a number. It takes a decimal number, and the 64 is just like how much it can take, the number of byte and stuff. So now let's publish to the message, not by our teleoperation, but we will publish by ROS topic pub. We will use the publish command to publish the values. ROS topic publish /turtle. Yes, /turtle 1/cmd velocity space geometry message /twist. Wow. So now you know the how this works. So we will put 2.0 0.0 and then we will do the bottom ones, like as you can see. No, dash. I have to put it in quotation. Dash quotation 00. And then another for the angular velocities. So 0.0 let's do a 10 or a comma. I forgot comma. How stupid I can be. Oh yeah, so let's first try it on 1.8, and as you can see, it's hitting the wall. It's hitting the wall. But I'll just start here. Battery low, just move it around here. And then we will launch this message again. So now as you can see, it goes front and turns. So let me show you why it just sends one message. So -1, this argument is for sending it only one type. So now here you can see they have mentioned everything. You should try it on your own. Now let's do it without the -1 command, like this. So now what we have to do is just remove that -1 and put a -r and 1 here. Control C, and then we will remove the -1. Where is the -1? There's no -1. Okay, -r 1. Okay, so as you can see, it just loops and repeats the messages. It's just sending the messages. So this one does mention, I don't know that, so I'll just keep quiet. Now let's see the RQT graph. What is the RQT graph saying? Let's refresh it. Yeah, so there's a teleoperation turtle and there's this ROS topic. which sends it to turtle sim. Though this message is different because we have closed this topic. We have closed this one, so there's no that using ROS topic LG. So LG is the uh, unit of frequency, as you know, hertz. Let's